Okay, so we are back to live streaming. Let me share my screen first. So we have solved till tries. In total, we have solved 75 questions. We have solved half of this sheet, and we can also include these three questions from array, which are easy. So 78 and one from this part, which is 79. So we are up to 80 questions. We are now left with important 60 questions, I can say, important 70 questions. Uh, so these are the advanced topics: graphs, advanced graphs, 1D DP, 2D DP, greedy, intervals, math and geometry, and bit manipulations. So it's 7:20. So let's start with the graphs part. So in order to solve graph problems, we should know DFS and BFS. So our most of the problems will be solved using DFS, depth first search, and BFS, breadth first search. So let me see if we have Sublime text on our system. I think we don't have Sublime text. Okay, so let's start with the first problem, number of island. Number of island, then we have max area of island, then we have clone graph, then we have walls and gates, then we have rotten oranges. Okay, I think we have some good problems here. So first problem is number of islands. So given an m into n binary grid, which represents a graph, which represents a map, one says land, zero as water, return the number of islands. Okay, so the problem is saying that we have this array, character array grid, which contains one or zeros. One represents land, and zero represents water. So we need to find a total number of islands. So for example, here this one, 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 and this one. So all are part of a same island. So we have a one island here. So in this question we have these four ones, and surrounded by these water means vertically, means in four direction, vertically and horizontally. We will check if it is surrounded by water. Okay, so here we have first island. This is the first island. It is surrounded by water. Then we have this second island. It is also vertically and horizontally surrounded by water. And this is the third island. So that's why here output is 3. So the question says we need to find these number of islands. So what we can do is we can start from every one. Suppose in this island we pick a one, we have picked this one, and then we can go horizontally and vertically, means we can use DFS to go in all directions and mark all these ones which are adjacent to it. So after marking these ones, we have found one island. Then we will go for another one. So in this one, we will mark all its neighbors having a value 1. So none of its neighbor has value 1. So we will mark it as uh, uh, true, means we have marked this island also. So now we have two islands. Then we search for another one. Then we will find a one here, and after this we will mark this one also. And after marking all these means neighboring ones, we can say that we have three islands, means three times we have to call the DFS. So the number of times we have to call the DFS will indicate that how many islands we have. So once we start implementation, then it will be clear. So first let's define length of this grid. Basically this is rows and this is columns. So what we will do, we will iterate this matrix and search for a 1. I less than row, I plus plus. For int j is equal to 0, j less than column, and j plus plus. So whenever we find a 1, what we can do, suppose in this particular case, we will find 1 on a 0 0th cell. So whenever we find a 1, what we will do, we will call a DFS. We will call a DFS and mark all the ones adjacent to this ones, means all the ones uh, present in four directions, left, right, up and down. So that will, what that will do, that will mark all these ones, these ones, this one also will be marked at this, and these ones also be marked, means all the ones will be marked. So we will be left with no one. So that's why we have in total one island. So we will call our DFS, will pass I and j. And how we can track that we have marked these ones? So we need a visited array. So we will create a boolean visited array with same size as of grid. So we will pass our grid and we will also pass that visited array. So as I have said that number of times we have to call the DFS will be equal to the number of islands. So let's initialize a variable count which will be 0. So whenever we call a DFS, we will increment our count, and this will be number of islands. And at the end, we can return our count. So now what we need to do, we need to implement our DFS function. So public void DFS. So we will currently we are at I position and I and j cell. So this is our grid and this is our visited boolean. So at first, what we will do, we will mark this one as visited. So we will mark ijth as visited. We will make this true. Now we will move in all four directions: this direction, and above direction and left direction. So these two directions are invalid. So how we can move into four directions? As previously I have defined explained directions vector. So this vector is helpful in going all four directions. So we just need to cramp it. Uh, so this is a variable 0, -1, 1, 0, and 0, 1. So what we will do, we will iterate this directions vector. So this is directions, this is current direction in this. So x will be my new position, that will be I plus dir of 0, and y will be j plus dir of 1. So suppose we are at 0, 0 position. Initially what we will do, we will pick this up. So this is our I variable, this is our j variable. So initially our dir will have this value. So my x will be I plus I is 0, 0 plus dir of 0. Dir of 0 is -1. So let me call this is -1, which will give my x as -1, and my y will be j plus dir of 1. So j is 0 plus dir of 1. So 1 is dir of 1 is 0. So this 0, this will give me 0. So now my x and y are -1 and 0. So what this represents? This represents one row above, means one row above means upward position. So in this case, upward position is invalid. So before moving, we will check that x should be greater than 0 and y should be greater than 0, means x and y should be within the board's constraint, and x should be smaller than mm, our this grid's length, and our y should also be smaller than grid 0 dot length. So after checking if these are in constraints, one another check we need to also add that our cell which we are going to visit should not be already visited. X and y should not be already visited. Then only we can call our DFS function. So now we will pass our x and y and our grid and our visited array. So this is how we have transversed our this particular island containing all ones. and in this case it will traverse this island which has four ones, and then we will move in the search of another grid having value 1. Then we will uh, go for this value, apply dfs for this value, and then we will apply dfs for this value. So that's how we will apply dfs for three values. Let's see if this works. Okay, we have some compilation error. Okay, we need to define it as array of array. Okay, in first case we are getting output 9. We are calling dfs 9 times. So what we need to also check here is that our current one should not be already visited. Means it should not be a part of a visited island. So visited should not be true. So in that case we will transfer it. Okay, so we are getting one island here, and for this case also we are getting one island. Let's see what's wrong. For this case also we are getting output 1. Okay, so one check we also need to add here is that the cell we are going to visit should be should have value equal to 1. Means we will only visit uh, cell having value 1, means having land. So x and y should be equal to 1. Okay, now our both test cases are passing. Okay, so this was the approach for number of islands. Now I think we can move to next question, sorry, max area of island. Okay, so these are islands basically having value 1, 1, 2, 3, 4, 5, 6. So like in this grid we have 6 islands. Means if we run our previous code which we have used on this grid, that will return us 6. And this grid has no area. So this question says you are given a M into n binary matrix grid. An island is a group of ones representing land connected four directionally, horizontal or vertical. You may assume all four edges of the grid are surrounded by water. Okay, so we are assuming that we have water outside this grid also. The area of an island is the number of cells with value 1 in the island. Okay, so for example this cell has an area of 4 as it has only 4 number of ones. So we need to find island with the max area. So here this highlighted island has max area 6 because it has 6 ones. So we need to find island having greatest area. So in previous question we have transversed every island to find the number of islands. So I think we can make a modification in previous question itself, that while transversing we can also count the number of ones in a particular island. Let me max area number of island. Let's pick this code up. Like what we are doing, we are finding number of islands here. Okay, so this code currently is to find the number of islands. Means this DFS runs on every island. So suppose we modify it something like that every DFS call will return as a area variable. Means return the area of the particular island. So what we can do now, we don't need this count, we need area. So let's call it max area. And suppose this DFS call returns as a current area. And then what we can do is we can define our max area as maximum of our max area and current area, and at the end we can return our max area. So that's what we need to figure out, that how we can modify this DFS function to give us area of the island currently in which we are. So instead of void, it will return a value. So whenever we find a one, we will call this DFS. So this ensure that we have at least one land area. So initially we can call our int area as one, because we are only calling whenever we find a one. So initially our area will be one. Okay. And at the end, uh, from all the four directions, we need area. That this TFS will return us the area from all the four directions. And after that, we will return this area. Okay. So we are initializing area with one because we are calling over this DFS function only when we get at least one means. So that's why we are initializing it as one, that our current I and j position have a variable one. And after that we are only calling our DFS only when one of the four directions has one. So then only we are calling our DFS function. So we will add up area from our these four directions to our this area variable, and we will return our area. So let's see if this works. Okay, so we have an error. What's the error? Incompatible type. So this can't be converted into this. Okay, so our grid is int here. In previous question, it was a character. characters matrix. Okay, so for the first case, we are getting a 0 as the output. Let's see. You may assume that all four edges of the grid are surrounded by water. The area of the island is the number of cells with the value 1. Okay. So we have grid's length, this visited array, max area for I equals to 0, I smaller than row, column. If our grid has a value 1 and the current cell is not visited, then we will visit our current cell. Okay, and this TFS will return area, current area. We will compare this with this area. We will take maximum of current area and max area. And in DFS, first we are marking our current cell as true and initializing our area as 1. Okay, here is the test result. We are getting 0 output. Hmm, let's take a small matrix example. Let's take a 0, 1, and 1, 1. So this should return as answer 3. What issue we are having? Okay, for here also we are getting 0. So our first DFS call will go for this this position 0 and 1. So we will mark 0 and 1 as true, define area as 1, then we will go in this direction. Let's say here also we have 0. We will call DFS for this. The initial area will be 1. Then we will check this direction will fail here, it's not 1. This direction, then we will call DFS for this direction, means 1 plus call for this direction. This direction's call will mark this as true, then initialize area as 1. Then check this position is invalid, this position is invalid, this is also contain 1, so this will not also execute. Then this will return area, which will be 1. So 1 plus 1 should be 2. So then why we are having issue? Test case. Okay, so now I have got the issue that why we are not getting answer. We are comparing it with the character one. We need to compare it with 1 itself, as it can be integer only. So let's run it now. Okay, at least now we are getting some 1 at least. And here also we need to compare it with 1. Okay, so we can submit it now. It it should it was not giving clearly because 1 has some value in its character form also. So we can check what that value it possesses by doing system.out.println uh, let's define char test as 1, and we can print it as integer value test. So it has 49 value. So we were comparing this value with the 49. So this has 49 value. And if we check value of our 0, then it will be 48. These are the ASCII values basically. We are printing ASCII value. So it is 48. So one has a value of character 1 has a value of 49, and minus 0 this have a value of 48. So this will also work. Okay. So we have question clone graph and walls and gates. So I think we should do question rotten oranges first, because rotten oranges I think has a similar concept like these two problems. Let's see. Fresh oranges, rotten oranges. Okay. Let's see clone graph. Mm, we already when we had last submission in June itself. So what should we do? I think we should implement clone graph itself. Okay, so we will implement a clone graph. So the question says, given a reference of a node in a connected undirected graph. So we have a graph, and this is the let's say this is a tree, and we are given a node, something like that. We have to return a deep copy of this graph. So what does a deep copy means? Suppose this is our original graph. So we need to exactly copy this graph and return a new graph. So this is a graph, and we cannot return the original graph itself. That will mean that we are returning the original graph, so we cannot do this thing. And this is the right way that we will return a fresh new graph with new nodes, which looks exactly like the original graph. And we cannot return a graph like this, means this graph is not exactly like this graph, because here we have three but here we have two. So this is the definition of our graph. We have class nodes, and we have neighbors. So our node have a value and it will have a list of its neighbors. So it is so what we can do, we can suppose do a DFS on this graph, and for every means every DFS part we can put a node into, we can create a corresponding node to that value. Suppose currently we are at node, this node, we can create a copy of this node, and then when we iterate its neighbors, then we can put neighbors also to that copy node. So I'm thinking like suppose we call a function copy nodes, VFS, on this node. And initially, suppose we have a node copy, and we will pass this copy node with, and at the end we will return this copy node. So public void and this node and this node. So if our this node becomes null, then we need to do nothing. We can return. So now what here means is our node is not null. So in that case, what we can do, we can put a node into our copy also. Means we can assign a object to our this copy also, copy node also, with the value of this node's value. Means this new node and value having same as this node's value. So this means we have created a copy node having same value as this node. So this is our first step. Now we need to have we have added this value. Now we need to add neighbors to our copy node also. So what we can do, we can iterate neighbors of this node. So current node neighbor node dot neighbors. So this for loop will iterate all the neighbors of our this node. Now we also need a list of these nodes to put in our copy variable, or we can initialize it like copy.neighbors is equals to new list of nodes. So we have initialized our copy nodes neighbors. So now we can, for each neighbor, what we can do, we can create a copy neighbor node. Means node neighbor copy. So copy of our neighbor node, that will be new node having same value as this neighbor node. So neighbor dot value. And then we can add this copied neighbor into our this list. So what we can do, we can copy dot neighbors dot add this neighbor copy. So we have added this copy, and now for this neighbor we can call our DFS, means this copy node DFS. We can move to this neighbor, and can and pass our neighbor's copy node. So instead of assigning this value here, what we can do, we can assign it here itself. Means we have initialized our this root node here itself. Then we will pass its copy, and we will create its neighbor list, and to that neighbor list we will add all the neighbors one by one. And after adding that neighbor, we will further call our DFS. So it is a connected undirectional graph. Undirectional means not having direction. So we need for undirectional graph we need a track of the visited nodes. We also need track of the visited nodes. So there are no repeated edges, no self loop in the graph. Value is unique. The graph is connected and all nodes can be visited from the starting given node. So first let's run this and see what issues we are facing. Okay. So what issues we are having here? So I think initialize a node will initialize its neighbor itself. The constructor will do this for us. So we don't need to explicitly uh, initialize this node, because the constructor is doing for us whenever we are creating this copy. Okay, so we are our code is getting us stuck into a loop, because the graph is undirectional and we are revisiting the nodes which we have visited. So we need to keep track of We need to keep track of the visited part. So the nodes which we have visited. So how we can track the visited nodes? Means what type of structure we can use. Let's see how many nodes we have. So the nodes are only 100. So we can use a set, I think. In set we can add the nodes which we are visited, which we have visited, like a hash set of node. And we can add our visited dot add this node to our visited array. And if our neighbor is visited, means if our visited array contains our neighbor, in that case we will continue. We will not call our DFS function, and we need to pass it in this call also. So let's see if this works for us. Okay. Okay, so the question is saying if this is a one node's neighbor. So neighbor of one node are 2 and 4. 2 and 4. One has neighbor 2 and 4, and 4, this 4 node will have neighbor 3 and 1. So we need to add this neighbor into this neighbor nodes also. So how we can do? Means the question is saying in this copy also we need to add we need to add new node. We have created copy this for node. Then we are iterating 2. So when we are iterating 2, we have created copy of 2, which is this. Then we are adding 1 to this copy. Now we need to add 2 to the 1. So we need to add copy here. Okay. दिमाग गर्म हो गया भाई. इसको BFS से भी कर सकते हैं. बेसिकली यही ट्राई कर रहा हूँ मैं कि ये जो नोड है 1, इसके नेबर में पहले 2 ऐड कर दिया, फिर 2 के नेबर में 1 ऐड होगा क्योंकि ये अनडायरेक्शनल है एज. बट यहाँ पे क्या हो रहा है इस टेस्ट रिजल्ट में कि 1 के नेबर में सिर्फ 2 ऐड हो रहा है, ये 4 ऐड नहीं हो रहा. 2 के नेबर में 1 भी ऐड हो रहा है और 3 भी ऐड हो रहा है इसके केस में भी. बट फिर 4 के केस में मीन्स 1 के केस में 4 ऐड नहीं हो रहा और 4 के केस में 1 ऐड नहीं हो रहा क्योंकि DFS पहले इसको विजिट करेगा, फिर ये डाल देगा इसमें, फिर यहाँ पे विजिट करेगा, फिर ये डाल देगा, फिर 4 के केस में ये यहाँ पे कॉल आगे नहीं बढ़ेगा. तो यही हो रहा है इशू. तो यहाँ पे विजिटेड मार्क हो जा रहा है, 4 के केस में 1 नहीं जा रहा, 1 के केस में 4 नहीं जा रहा. तो फिर not visited. Three calling one. Sure. Okay, so I think we have a. So what GPT is saying? GPT is saying the issue with your implementation lies in the following line. So in this line, our issue lies. So I think I have also written here as the issue. So that's what I have thought. This condition check if a node is already visited. However, you are creating a new copy of neighbor in every recursive call, which leads to duplicate nodes being created in cloned graph. Incorrect graph because the neighbor will not refer to the same clone node but instead refer to the new copy node. To properly clone the graph, you need to maintain a mapping between the original node and their cloned counterpart. Okay. To properly clone the graph, this condition check if already node is visited. However, you are creating a new copy of the neighbor. In every recursive call which leads to the duplicate values being created in the cloned graph. Here's the correct implementation. If node equals to null, then we have created a map. In that we will check if this node exists, then we will return the node, create a copy of current node, node clone, new node value. We will put this node against this clone. If the node is already cloned, return clone. Values are unique, so we are maintaining integer. Find adjacent list. So okay, so first we are creating duplicate, means we are creating a map against each node. Then we are forming a graph. Okay, so in this approach, we are doing. We are first mapping a, means creating a copy node against each node, and then we are using that copy copy to fill that node. But what issue here we are doing? First, we are creating a copy. Then we are marking the node as visited. Then for each neighbor, we are adding copies to each other. Okay. So this condition, here we are creating a map node, then calling this function. Then if our map contains that node, we will return corresponding node to that. Otherwise, we will create a clone and put that into our map and call that function. So we have merged these two functions, this one and this one, into one function. Like instead of calling this here, we will calling a node map and checking if our this node map contains key. If this node map contains this node, then we will return corresponding copies. Let's call this node function, return this function. Otherwise, we are creating a clone and putting that into our map simultaneously. Map.put node against clone, and then we are adding that to our clone lists neighbors. Means we are adding this call clone dot neighbors dot add this part and returning node at the end. Okay, I have understood this approach, but not able to understand that why our approach was failing here. Okay, so the question is saying that when we have created one neighbor for two, then for checking neighbors for three, what if we have multiple nodes? While this code links the clone of the current node copy to the clone of the neighbor, it fails to account for cases where neighbor has been already visited. Instead of connecting to the existing one, it creates a new incorrect clone of the neighbor. So for this example, we will start with node 1, create a copy of node 1 with value 1, add 1 to the visited. Okay, added 1 to the visited. For node 2, since node 2 is not in visited, create a new node, neighbor copy with value 2, add copy, node 1's clone to neighbor copy, and neighbor add to the recursively call copies for a call to node. Okay, now we will go for 4 node. Similarly, creates a for 4, add a copy of once and add it to its clone. When processing node 2, creates a clone for its neighbor 1 and 3. Since 1 is already visited, DFS skips it. A new clone for 3 is created. Okay. But this will lead to duplication when processed again from node 4. Similar issue arises when multiple nodes are created for node visited. Okay. So instead of visiting, we are not able to visit all the nodes. So I think GPT is not getting it. So we are not able to iterate this force neighbor at the end. So that's why this approach is failing. So our previous approach was better. So we can revisit this question once again. We can mark it as a important question. It's a good question. So I think that is it for today. We will solve these 2 or 3 problems tomorrow.